Let's find the limit as x approaches 8 of x plus 8 over x squared minus 64. So to get started, we want to simplify this expression as much as possible. And if you notice here, x squared minus 64 can be simplified down by using the difference of squares. So this can be factored into x plus 8 times x minus 8 because it's in the form of difference of squares. Plugging this back in here, we can rewrite this expression as the limit as x approaches 8 of x plus 8 over x plus 8 times x minus 8. If you notice here, the two x plus 8's cancel, and so our final limit expression will be the limit as x approaches 8 of 1 over x minus 8. We can now use this and plug it into this framework right over here. So to plug it into this framework right over here, the first thing we want to do is evaluate f of a. So we're going to plug x into here, and you're going to get 1 over 8 minus 8 is 1 over 0. And so this is this first option right over here. And so we know that this means that there is a vertical asymptote right at the location that we are looking at, right? There is a vertical asymptote. So now we want to find, does it either approach positive infinity? This would be if the two graphs look like this, and then this is the x position that we're looking at, right? This is an example of approaching positive infinity. And then if, on the other hand, it went down like this, right, at the position, this would be an example of it approaching negative infinity. But if one side approached positive infinity and the other side approaches negative infinity, this is where we say that the limit does not exist. And I'm going to write this as DNE, does not exist. So let's find out if the limit exists or not. To do this, we're going to be plugging in values. We're going to be basically computing two different limits, right? We're going to be computing the limit as x approaches 8 from the left or from the negative side, and we're also going to be computing the limit as x approaches 8 from the right or from the positive side. So to do this from the left side, we're going to plug in a value that's less than 8. So let's start by plugging in 7. When I do this, I'm going to get negative 1. Now let's plug something in that's a little bit closer to 8. So let's try plugging it in 7.5. This will get you negative 2. Plugging in 7.75, getting even closer to 8, you're going to get negative 4. So you can see we're getting more and more negative. So this is a case where when you're approaching from the left side, we can say that the limit is negative infinity. So now we're looking to see if it matches on this other side. To do this, we're going to again plug in values now that are greater than 8. So we're going to plug in 9. This is positive 1. If I were to plug in 9.5 to, or sorry, 9 point, let's see, or 8.5 to get closer to 8, right? This would get you 2. If I were to plug in 8.25 to get even closer to 8, that would get you 4. So as you can see, we're getting greater and greater and greater, more and more positive, right? So as you're looking from the right, you're approaching positive infinity. So we have this third section here, this third option, that's where we're at. So that's why we can say that the answer to this is that the limit does not exist.